Hi! For my battery leakage testing project, I thought it'd be really cool to actually add a voltmeter to every one of the four AA batteries. So I have a separate voltmeter display on there so that we could see if any of the cells actually go negative voltage and whether or not that's related to any of the leakage, because it very well could be. So rather, I've got a million multimeters here, but then, this thing could run for months. And, well, continuous, yeah, you can turn off the auto power off on your multimeter. Usually that's a power on option. You can turn off the auto power off, but the batteries probably aren't going to last. Typical meter with 300 hours. Yeah, it's probably not going to last. So I thought I found these old panel meters. I've got a whole bag of these. I actually, a former company that I used to work at, I can't remember which one now, but like throwing out some old gear or something, and I had a whole bunch of these, like a customized, I think it was part of a customized test rack or something. And of course, all the circuitry inside was totally custom. It was, of no use, but I think it was going in the dumpster or something, and I thought, oh, and I had a whole bunch of these panel meters on it. I can't remember what it did, or even if I was involved in it or what. I can't actually remember. But yeah, they had like dozens of these panel meters. So I thought, not throwing those out. So I went in there and I opened the thing up, and sure enough, they had like a pin, a pin header thing on here, so I didn't have to desolder anything. Just pulled them out, snapped them out of the front panel, and I salvaged all of these panel meters. And you've probably seen this before, because I think I used it in the electronic load video, which is probably like a decade old now at least. And yeah, I don't think I've used one since. Maybe I have, but anyway, I totally forget what model number and spec this thing is. Well, apart from, I believe it's a 2-volt panel meter. Usually they're like 200 millivolt panel meters, because they're 19. I know I'm pretty sure it's, well, you can probably see the digits on there, can you? I think it's 19999. So yeah, I think, but I think this model is a 2-volt panel meter, or they might be mixed. I don't know. I never actually tested them after I got them out. I just knew that they were working. So anyway, I thought I'd just have a look at getting this thing up and running, because I don't know the model, I don't know the pinout or anything. So let's crack it open. And looks like it's got some tabs there, and we'll see if there's a model number inside. I could probably go and watch my old electronic load video where I think I use this panel meter. Maybe I showed how to hook it up or how to figure out what it did or whatever. I don't know, but that's pretty boring, watching my own video to get the answer. So I'm going to do it. There you go. It's got new CX101. Yes, I remember that now. Okay, _1. Don't know what that means. Because there are different variants, and I think these are like, you put the resistors in a certain, or maybe jumpers or resistors in a certain, maybe down here, or no? Yeah, anyway, there's a few unpopulated footprints. So yeah, you can get like different voltage range ones. 200 millivolts, 2 volts, 20 volts, maybe even 200 volts. I don't know, although it doesn't look like there's clearance on there really for, a 200 volt jobby. But anyway, we've got the black blob. KFU? Oh, FR4 is just the flammability rating. That's what FR stands for. If you didn't know what FR4 PCB stood for, it's the flammability rating. FR4 technically has nothing to do with the actual, otherwise the material, well, it does. It's all part of the flammability rating. But your standard FR4 PCB, it actually stands for its flammability, how easily it catches fire and stuff. So there's E1620223. Okay, so but no, I think that's the model number, the CX101. So let's Google that, shall we? Now, before we actually do that, it's going to be obvious that I think these 2 pins over here are your power pins. It's just obvious. They're going to have them separated. And there might be a link in here also to whether or not you have a common ground or an isolated ground. I want an isolated ground, because I want to power all 4 of these, obviously, from a separate battery. Like, it's probably like a 5-volt panel meter or whatever. So a 5-volt source. But then I want the isolated ground. I don't want a common ground. So we should be able to actually measure that with an ohmmeter. So yeah, anyway, let's go have a look. Here we go, CX101 panel meter, new mini LCD panel meter, circuit specialist, 17 Yankee bucks a pop, 5-volt independent, that's the one, yeah. EEV blog, of course it's the EEV blog forum. Everything's on the EV blog forum. Let's go look it up. Geez, this middle button's not working properly. Of course it's on the forum. Everything's on the forum. Look at this. Oh, I'd like to build a constant current load like in Dave's video. There you go. It's number 102. And is confused by the CX101. Yeah, BG version. Works with common ground. Okay. Thing doesn't seem to exist anywhere. A circuit specialist. There you go. Is this thing discontinued? Okay, so that was the CXBG. So it's the BG I was using, was it? I don't see it, but we just had a -1 there. Plain vanilla digital panel meter with ground reference input. It's also got a current sense shunt. There you go. Oh, no, 100K. No, I'm not seeing a current shunt. So maybe you can put one in? I don't know. No, but all those values are way too high for a current shunt. This one, miniature LCD, 5 volt, common ground. I hope it's not. The 101B is a 5 volt version. 101A is a 9 volt version. The BG is a 5 volt version, which can use a common ground. Okay. Right. Well, our one is just CX101. So, current shunt's external. Okay, there you go. Signal to be measured. Blah, blah, blah. Okay, yeah, that one's definitely common ground. Okay, so it looks like pin 6 is your ground input like that. 3 and 4 are not connected. Okay, yeah, and then where you want your decimal point. Neat. What else have we got? You can get an eBay pack of 3 on eBay for 55 Yankee bucks. Glad I got a bag of these. EV blog forum again. Shenzhen OPL display. CX101 LCD panel meters in stock. Yeah, nah, that's certainly very different. There you go. That one's got the jumpers on there. But it looks like this CX101 is like a thing. And it's probably got a common pinout. So yeah, here's the here's the BG version. So yeah, it looks like this is the modern equivalent. Oh, are they resistant? No, there's not any. No, there's no big resistors on the other side because this one can go up to 1,000 volts. That's why it's got the big resistors in there. So no, not the same thing, but I reckon the pinout's going to be the same. Yeah, 9 volt, 5 volts, common ground. Oh goodness, I hope not. Well, we can measure it and we can test it as well. 0.1% plus 1 digit. Schmick. These are nice panel meters. 2.5 times a second. True differential input and reference. Yeah, those pinouts. Oh, geez, that's a dodgy data sheet, isn't it? Can I find better? This one's better. 100 mega ohms input impedance. Auto 0. This is the 7 to 11 volt version or the 9 volt version. Once again, it can go up to 1,000 volts. I think this CX101, we might have the OG here. We might have the original gangster CX101 design here, because this is not the A. This is like _1. So, yeah. Anyway, so in negative, so here we have a better pinout. I'm sure that is proper. So there's the common, input low, input high. Okay, so you just join all those together and power source. And, okay, so that's just the common, but that won't be connected over. So that should be isolated from there. Only one way to find out. Let's measure it. So ohms, pins. Okay, this is ground, and pin 5, 3, 4, 5. Oh, sorry, no, I think it's that one. So none of these are connected electrically to the ground. So, ta-da, float in, Bobby Dazzler. All right, so let's apply power and see if this is a 5 volt version. Oh, we didn't check that number there, did we? I think that's a 3. E162023. No, that doesn't seem to the digital multimeter PCB, but it doesn't really seem to be a thing, does it? Reproductive, no. Okay, this is another one. There you go, E162023. But once again, it's this, I guess, newer version that has, well, it's the one that has the high voltage jumpers and the dual row pin header on it. All right, so let's up that to 5 volts and 200 milliamps to 500. Drop it right down. And I've just bodged up a lead here. I had this lead, so black there. Yep, it works. Look at that. And it's slowly going down. That's what I'd expect, because that is capacitive buildup. And yeah, so if you don't touch anything, it will go down. Yeah, so this is 100 meg input impedance. This is high. It's not 10 meg. This is really high. So if we wiggle, yeah, around there, yeah, you'll see it go up. Whoa, hey, I just overloaded it there. And if we short the input, it'll go back down. Okay, so what I got is another lead here. Now, that first one I'm going to skip because it's not connected. So I think I might be one short though. It looks like I have to short that pin to the one next to it, but I can just do that manually, I guess, even though the other end is here. And conveniently, so that should be, so I short black, brown, and orange there, apparently, according to the schematic, and that should be our input. So I'll hook that up to another floating power supply here, so not common. So this pin over here is apparently like a reference in and out or something. So I'm not sure, but it seemed to be measuring something. So maybe this one's slightly different. Maybe it doesn't need, you know, it's got an internal reference and you have to strap it externally to make it work. I don't know. So let's knock, oh, sorry, it's off screen. You can't see it, but there's another power supply on the left-hand side here. I'm going to take that down to 1 volt. So I'm going to hook that up. Well, we get 1. Where's the other digits? Hello? Maybe if I short the input. No, short the input does nothing. Okay, well, yeah, maybe I have to strap those references. Yeah, you see, RFH and ROH. So reference output high and reference high and reference low. Yeah, okay. So 9 and 10 have to be strapped together. Something's happened. We got 303, so I just strapped yellow to white there. Just shorted those together and, there you go. I just shorted the pins out. Sure enough, it went to 0. So, sorry, I can't keep this like upright. I need there we go. That's better. I'm going to touch the red wire there. Yeah, it goes up. Yep, no worries. And short it. Goes back down to 0, no problem. Yeah, it needed that, it's got an internal reference, but it needed you to feed that in. So, yeah, otherwise it wasn't going to do the business. We'll feed in our 1 volt, and we should, no, it's 200 millivolts. All right, maybe that's why. Maybe it didn't need the reference. Oh, no, but I shorted them before and it didn't go down. So, okay, let me adjust this power supply again. 100, yep. So, unfortunately, it's a millivolt one, which is no good for my battery, because obviously the battery's 1.5 volts. So, 200 millivolts, full scale, is not going to cut it. Of course, I can use a voltage divider, or I can try and figure out if there's anything in here. But anyway, it works. We have a nice little 5 volt isolated panel meter here, very accurate, 0.1% plus 1 digit, very nice. It's upside down, so all the electrons are going to fall out. We do have an adjustment pot, which is interesting. For such a accurate thing, they've just tweaked it. They haven't used precision components, so yeah, unfortunately, they're not labeled or anything. Maybe I figured this out before. Maybe I should go watch my original video. I can't remember if I used a 2 volt or a 200 millivolt range for the panel meter. Do it yourself, constant dummy load. There you go.
Welcome to the
EV blog.
An electronics engineering video blog.
Look at the old Altium board. I've done a video on that.
Dave Jones.
I manually spun that with my with my 3D space navigator. Because when you worked at Altium, as soon as you got a jump, they gave you a 3D space navigator so that you could, they were all the rage at the time, so that you could rotate the boards. And I rotated that by hand and did a screen capture, and that's how I got my intro. Look at this. When I put the episode number over there and everything. My Flying Spaghetti Monster Engineering Religion t-shirt. Oh, I need to put that back on the store. So anyway, there's my constant current load. And yeah, I would have just been measuring the voltage across the 1R across the bottom there. So, yep. So yeah, CX101, there it is. Yeah. So I only need the 200 millivolts because the burden voltage of that's not going. Here we go. Look at that. Common ground LCD panel. There you go. Tweak for 0. No, I whacked my 100 millivolts in and it measured it fine. So I don't know why I thought that I had to use, maybe I found a data sheet back then that said this is what you use. There's the reference there that you have to tie back. We just did that. And your other 3 pins that are unused at the moment are your decimal points. So you just strap it to whichever decimal point you want to use. It's not like an auto ranging thing. Panel meter is designed for 0 to 200 millivolts input. This will do from 0 to 2 volts or 0 to 2 amps. So my display of 1999 will read directly in milliamps with a 1 ohm load. Oh, okay, that's why. I was using a divider. Okay. So yeah, that makes sense. I was using a divider there, and yep, okay, but we don't need that. So there you go. There's my battery capacity logger that I had at the time. Still got that board somewhere, I'm sure. Geez, look at the date code on that, 2004. Wow. I can't remember what I built that for at the time. Yeah, I was doing something. DLJ with a smiley face there. Look at that. It's working on something. S1, that's a Surcell part number, so that must have been for Surcell when I was working at Surcell at the time. So yeah, the part number started with S there. So, oh yeah, it's got Surcell on it. There you go. Anyway, that's got nothing to do with this. Oh, pretty comprehensive video. Look at this. So anyway, yeah, that's the answer. It looks like I didn't figure out a way to internally strap it. It looks like I just used an external divider there. So in low, yeah, so it's just divided, you know, because you've essentially got even though I tied this as a common here, you don't have to. You saw it. It worked fine as an isolated thing. Yeah, so I definitely don't want to put that in because I was just powering it all from the 5 volts, so I commoned it. But in this case, no, I want to power the power supply. I want to have a separate 5 volt supply for the 4, because I've got 4 panel meters across 4 individual batteries that are all electrically connected together. So yeah, you don't want common ground. You're going to come a gutsy, you're going to short out your battery. That'll ruin your day. Although it's not going to explode, it's just an alkaline. You know, ESR's reasonably high. It'll just get warm. So there you go. That's the answer. Old school Dave Cat. Could have saved myself this video by just simply watching my old video. But that's no fun, is it? Like, I could try and reverse engineer it and try and feel like there's nothing written under there, is there? Which reference does it use, by the way? LM285. There you go. Yeah, like, if it had like a 2 volt thing, I'm sure they would have labeled it. Like, you know, not guaranteed, but yeah, it's the nice thing to do. And you saw on the other models that they had it. But yeah, this might be one of the original OGs, just so they're all 200 millivolts. A long shot, if you do actually have a circuit for this, or any more details about any potential strapping in there for a 2 volt mode, then let me know. But it looks like I don't see, like, there's no 0 ohm jumpers in there. I'd expect to see like a voltage divider thing, like maybe like 2, you know, and there's more than, well, there's at least that one missing and that one there. They're both missing. R5, Q1, what's that? C, is that a, no? Yeah, that's a resistor. So there's 2 resistors missing there. There's 2 resistors missing there. And if it did actually have a strappable 2 volt mode, I would have expected to see one of them strapped with a 0 ohm in there, just a link bypassing. And if you wanted to put 2 volts, then you put in your ×10 voltage divider in there. So yeah, I doubt that this has 2 volt capability built in, which is a bit of a bummer, but I can put in the external resistors. But yeah, just adds to the work. I thought I could just maybe wire it straight in. I thought from memory that these were 2 volts, but that was from my rusty memory of the original video from a decade ago, and I used resistors to use the voltage divider. So I'm going to have to do that here. I'm going to have to do it 4 times. That's a bit of a bummer, but anyway, yeah, so if this battery leakage thing does work, then I want to like engineer like a proper, I'll actually design a proper PCB with these 4 panel meters, and I'll have like the individual like cell holders and everything. Like, it'll be, you know, be quite jazzy, and I'll have the 3 555s on it, and yeah, I can, like, it'd just be nice to be able to do that. Of course, I could like data log the batteries as well. We're talking about a month, and like, or months. You know, you might leave them there for 3 months, 6 months, who knows? And these panel meters don't use much power, so I can probably run it off like a just the panel meters off a battery, and they'll run forever, maybe, or just a separate 5 volt external plug pack supply. Something like that. Anyway, there you go. Panel meter. It works, but yeah, Needs some additional voltage divider doodads. So if you like that video, give it a big thumbs up. As always, discuss down below. Catch you next time.